Hi, everybody. This is Mr. Folly, and welcome to 1.1, first page, first part, test one. Let's hop right to it for chemical. All right, so matter is anything that has mass and takes up space. So it's got to have both of those. However, it's got to have both of those. However, it's really hard to have one, but not both. So that's the part that just kind of got to be ready for. Oops, I forgot to put Mr. Folly. Pure matter comes in two forms, right? An element and a compound. So if it's pure, that means you're only one thing, okay? And that's going to be an element and a compound. So let's talk about what an element and a compound are. A pure element is only one type of particle. An element is one thing from the periodic table, but it can be diatomic. So let's look at some examples. So do you see how right here, my element, my one particle, is the white thing inside of there. I don't know if that's a hexagon or something. I think it was supposed to be. This one has just a circle. Okay, so my particle is a circle. Now notice I'm looking, do I see any triangles? No triangles. Do I see any squares? No squares. It's pure. It's all the same. There's nothing in this space except for circles. Okay, this is diatomic. Simple breakdown root words, two atoms at once. Do you see how they're touching? So if you've got a touch, that equals a bond. So if you hold somebody's hand, oh, that's a bond. Oh, my little snookums, I hold her hand in the hallway. Or I'm 4 years old, though Mr. Foley holds his mama's hand, and that shows a bond of whatever, of the family. All right, so take a note right here. Each shape is an atom. Circles are different atoms from hexagons, triangles, or squares. Touching means bonded. Na and Xe have no bond. See how there's nothing touching on Xe, nothing touching for Na. H2 does have a bond. Okay? Packed in tight means it's a solid or a liquid. Space between the particles means a gas. So this would be a gas. This would be a gas. This would be probably a solid. And solids, you can usually tell, are also neatly lined up too. Diatomic elements are two of the same type of atom bonded together. There are 7 universally accepted diatomics. I call them, get ready for this, North Coolbree H. North Coolbree H. These are used now but need to be memorized for the Unit 2 exam. So we're going to use them, we're going to refer to them. The better you know those, that's Unit 2 exam, we're in Unit 1. So just know that's coming. AT2 is argued to be diatomic, but the results are inconclusive, and really it's kind of a matter of opinion. It's like, do you say the cup is better than the size? So that's kind of the deal. Pure compounds, only one type of particle, but there are 2 or more elements bonded to it. Compounds are unique from elements they are made of. H2O, that's water. I think that's the one compound I think you should know. Is different from H2. If you put a match to H2, boom, explosive. You put a match to O2, fire, 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 right? If you breathe oxygen, my life, it's still going. If I breathe hydrogen, my voice gets very squeaky until I pass out because I don't have any oxygen. If I breathe in water, I become an X person. Picture of NaCl, so some different pictures of them packed in there again. So notice how my particle is this right here. My particle is that right there. And notice how that's just repeated over and over again. Okay? Touching represents bond. So sodium chloride, these ionic ones, man, are they hard to tell what's going on. This forms a lattice, so you can keep looking for a repeatable pattern. I guess I should have gone this way. Looking for a repeatable pattern that you can see over and over and over again. Touching represents bonds. Sticks connecting shapes indicates bonds. So this is a new way to indicate a bond. Okay? That's the sticks indicating, connecting them. A particle is one Mickey Mouse for H2O and one of those dudes for CH3OH. Okay? Formulas. Elements have only one type of atom, K, Kr, or Cl2, one type of atom. The type is K, the type is krypton, the type is chlorine. Compounds have more than one type of atom. Potassium and bromine, carbon, hydrogen, chlorine, hydrogen, and oxygen. Okay. Let's take a look at mixtures. Heterogeneous mixture. By the way, this is a heterogeneous mixture. I'll make that a little clearer. Hetero. There's more than one type of particle. Okay, what does that mean? Here's one type of particle, double big ring, single one. Oh my gosh, it's got three, right? This shape has three particles. It's unevenly mixed. Not every sample is the same. So notice if I just drop a line right down here, do you see how the left side is different from the right side? Okay. Now what's hard about that is it's got to be any sample. Okay. So if you're heterogeneous, not every sample is the same. If there's a blend of properties, salad tastes like a carrot blended with ranch dressing. Okay, that means when I do that, I taste carrot, carrot, crunchy, crunchy. I taste ranch dressing, perhaps the greatest taste ever made on earth. So there's a blend. You taste both of them. Okay, if you taste a bite of bread, you don't taste, I taste the flour, I taste the sugar. A heterogeneous mixture means that you can tell the different parts. All mixtures have blends. Okay, that's how you differentiate a mixture from a compound. A homogeneous mixture, more than one type of particle. So like above, the types of particles, right? It's perfectly evenly mixed. So these are almost impossible to draw because they have to be perfectly designed. So it's really hard to make every sample be exactly the same, especially when you use like compounds and stuff like that. So do you see how it's got to be like every other one? And that means that every single sample has to be the same. Okay. Blend of properties. Sugar water is wet and tastes sweet. Remember, sugar water, every taste is the same. Okay. Now, homogeneous mixture, there's two other specific things you should know for a homogeneous mixture. Anything that's a solution, which is, and this is a cheesy definition, it's stuff. Whoa, I put 3 F's in stuff. That must be a lot of stuff. Dissolved in water. Oh no, my pen's not working. Okay. And the other one is an alloy, which is a mixture of two metals. And your alloys that you should be comfortable with are steel. Steel is not an element or a compound. It's a mixture of metals. And the same thing is true for brass. So they're a mixture, and that blend of properties is wonderful. Okay. Note, mixtures are defined by sampling. If I ask you to describe a homogeneous or heterogeneous mixture, you don't say the word sample, you're probably wrong. Homogeneous, homo means same. Samples are the same. Heterogeneous, hetero means different. So you need to have different samples. So if you take 2 samples, they'll be different. You need to be able to identify a compound particle, an element particle, diatomic element particle, and other shapes besides circles are common. I tried to give you some other ones, but that's it. That's it. So to that, I will say toodles. Uh-oh.